All right, good morning. How y'all doing? We're going to be doing, geez, what was this? I forget the number. Well, it's period, it's lesson two, two-way relative frequency tables. All right, it looks like this. Let me see. It's number 14. It's number 14, sorry. So this is number 14, two-way relative frequency tables. This two-way relative frequency table is going to be a lot like the frequency tables we already did, except now instead of having like the joint frequencies being like an actual number of frequency that something occurred, instead it's going to be the relative frequency, which is like kind of like a percentage out of one. All right, you'll see how that goes. All right, so it should look like this. Oh, I want to make sure. Okay, good. I'll make sure I was recording on the right page. Uh, a relative frequency is found. So a relative frequency is found by dividing the frequency count by the total number of observations. A relative frequency can be expressed as a decimal or a percentage or a fraction. So here we have example one, which we're going to show you what we're talking about here. Um, Consider the two-way frequency table from the previous lesson. So you guys have all seen this before, right? This is that one where there was a survey of 1,000 people, and they took 450, randomly selected 450 random surveys out of that 1,000, and then this is the data that they got from it. And so this 49 here is the females respondents that said they wanted to fly as their preference for a superpower, and then like this 26 over here the 25 over here is number of males that wanted super strength from the survey. The 26 would be the total number of respondents that wanted super strength in total, right? Okay, so remember this. If you haven't seen this before or this doesn't look familiar to you, look at the previous lesson, where we go over how these tables are interpreted. So a relative frequency table is like the ones you've seen, like this one here, but just a little bit different, right? So for instance, to fly here, and before we had 49, right? There was 49 females that chose they wanted to fly as a superpower. But now we're going to do the relative frequency, which is 49 divided by 450. Where do they get that 450? That's that total number of respondents, right? By taking 49 and dividing it by 450, what we get is a calculation here, which gives us an idea of the relative frequency. In comparison, in relative to everything else, and relative to the total, what was the percentage or decimal out of 1 for this number here? So males, how would we do this one? So males, so we had over in our two-way frequency table, we had 51, right? So we're going to kind of do what we did already. 51 divided by what? 450, divided by the total, right? And I'm okay with the way it is, but I want to kind of stick with the format. It says you got to use the equation editor or something in here, so I want to stick with that, so it all looks the same. Sorry, I'm struggling here. I don't know what to do. I'm trying to get this thing to select. How do I select this thing? Nope, that's not what I wanted. Sorry. Technical difficulties. Technical difficulties. We may. There we go. There we go. All right. So here's what I'm going to do. I'm actually going to just copy and paste. And notice how that was tricky for me. I'm going to copy and paste this so I get the same kind of thing going on. But instead of 49 up there, I want 51. And instead of this calculation right here, I'm going to need to recalculate on my own. So this goes away. Looks like we're rounding to the nearest thousandths place. So I'm just waiting for my calculator to pop up here. Anytime, Webbit, EMU. Just waiting for that calculator. I probably need a better computer. All right, well, I guess while I'm waiting for that calculator to do its thing, I'll just I'll copy this and I'll paste this in a few times, right? I'm just pasting the same darn thing in over and over again, knowing I'm going to have to fix it. So that way I don't have to mess with figuring out that equation editor on the fly and wasting all your time. And by the way, in terms of speaking of wasting your time, remember, these videos can be paused. These videos can be fast forwarded. These videos can be slowed down. They can be sped up. If I am going over something too fast or you need it slowed down, you can always slow down the video. I just want to remind you that you have total control over these, and make the best use of these for your instruction. Is my calculator up yet? Oh my goodness. My computer feels so slow today. You ever had those feelings on your Chromebooks? It's just moving like molasses. That's what I'm feeling right now. All right. Okay. Now that I've got all that in, is my calculator up yet? Oh my goodness. Well, um, oh, oh, this is double ungood. I clicked the wrong thing. Yeah. Oh, jeez. All right. I'm going to try to make this work. I'm going to try to make this work. I clicked the wrong thing, and now I'm worried that my video isn't working. Maybe it is. No, it's not working. There's an error. Okay. I don't know. Screencastify. So I'm trying to use Screencastify as a more. Okay, it says I'm being recorded, so I'm going to trust Screencastify. But the calculator thing is really bugging me. That should have been like up like so far long ago. Oh, where'd my tab go? Oh, there's my calculator. Oh, annoyance. Annoyance. Okay. Uh, all right. I'm sorry. I'll tell you. I'm learning. I'm learning. Okay. I'm using a new tool. I'm using the Screencastify to record because my YouTube streaming thing that I was doing before sometimes was just finicky. And anyway, so where was my calculator? There it is. Okay. That's what I wanted. Thank you, computer, for finally giving it to me. Um, just so you all know, the struggle is real. All right. The struggle is real. Okay. 51 out of 450, right? So 51 divided by 450. Do you remember where we are anymore? We're over here. We're on males that wanted to fly, right? There was 51 males. Oh, I regret clicking on that. There was 51 males that wanted to fly, right? So here I am. I'm doing 51 out of 450. 450 is the total number of respondents to give myself a decimal out of 1. So I get this 1.3333 thing. And I want my screen to be on top of this. I know. I want too many things. I want too many things. I want to be able to click the calculator and not have my screen um, disappear every time. And now the tab is huge. Can I make this tab any smaller? Oh, I can make the tab smaller. That's cool. Can I make the tab any shorter? No, it looks like that's the best I can do. Okay. Well, sorry about that. Still working on the technology things here. I'm there now, finally. Okay, I'm happier with this. All right. So now I can actually look at my calculator while I type on the screen, and that is going to come in handy to me. So 0.113, and the next this little space right here, that the 10,000th place is a 3, which is 5 or less, which means my 3 stays the same when I round it. All right, there I go. I've got the males that wanted to fly here. For freeze time, of course, I got to get rid of the 49. In fact, I wish now that I've done this, I wish I had actually done it. Again, this is where Mr. Salt gets persnickety and wants things a certain way, and that sometimes gets me in trouble. So I wish I had taken out the 49 and taken out the answer and left this little piece and then pasted this instead of having essentially the wrong answer a whole bunch of times and I'm going to fix it. I rather wish I had done this way. But we'll just roll with it. We'll roll with it, right? Okay. So the females that wanted to freeze time. The females that wanted to freeze time. Well, that's 60, right? So we're going to do 60 over 450 here. I'm going to do that in my calculator. 60 over 450. 1.33, okay. Or 0.133, repeating. 0.133. Again, I'm rounding kind of automatically there. I see there's a 3 in the 10,000th place, so this stays the way it is. And let's do this next one. Males that wanted to freeze time. Males that wanted to freeze time, 71. There were 71 males that wanted to freeze time. So I'm going to delete the 49. I'm going to stick in a 41. And then I'm going to go to my calculator, 71 divided by 450, right? I'm finding out what percentage of respondents were males that wanted to freeze time. There were 71 of them. So it's 0.15777 repeating. Okay, so think about if I want to interpret this result, I'd say about 15.77%, right? 15.77% of respondents were males that wanted to fly. All right, 0.157. No, the 7 has to go up to an 8, right? Because there's in the 10,000ths place there's a 7, which means in my thousandths place I round that 7 up to an 8. So 0.158. All right, you kind of feel how this is working out? You kind of feel how this is working out? I'm just doing some housekeeping over here. Whoopsie daisy, I didn't want that. I need that. Huh. I need to explore more with this equation editor in Docs, and I just don't want to experiment with it right now. I want to do that on my own time when I'm not recording a video. So it's not to do too much of this housekeeping stuff. So, all right, so let's try to do another one, right? So invisibility, females invisibility. What's the relative frequency of females that chose invisibility? Well, there was 48 females that chose invisibility. There was 450 total students that chose it. So I'm going to put a 48 here. 48 divided by 450 will give me the relative frequency of females that chose invisibility. There were 48 out of 450, which gives us 0.1066 repeating, right? Okay, so 0.106. And in the 10,000th place, there's a 6, which means my 6 rounds up to a 7. Actually, that's what that little squiggly means, that little squiggly equal signs. That means approximately, right? It indicates that we have rounded. And that way you know the answer is not exact. It's an approximation. All right, so let's see. Males that wanted invisibility. 27. There were 27 males that wanted invisibility. So we're going to find out 27 out of 450 of the males that wanted invisibility out of the total number of students. What was the approximate percentage? About 6%, right? About 6%. 0.06. Whoops, that's not how I wanted that. 0.06. Okay, so we've done a few of these now. And there we go. I like that better. We've done a few of these now, and I was thinking, before I start thinking, let's do some of these marginals, right? The marginals are going to be pretty similar to what we've done so far, right? I want to find out the relative frequency of just students, males and females, that wanted to fly. So there was 100 total respondents that wanted to fly. That includes males and females. And so I put a 100 in here. I'm almost afraid that you guys can't see. It's kind of small. Okay. Well, hopefully you can see that. 100 divided by 450, right? 100 divided by 450, right? The total number of people that wanted to fly divided by the total number of people gives us a relative frequency of what percentage of people wanted to fly. It's approximately 222, repeating. So about 22%. About 22%. Similar here. Oh, this one was already done for us, right? 131 total people that wanted to freeze time, males and females together. 131 divided by 450, it was approximately 0.291 or 29.1%. And that's kind of how it's done, folks, right? Total number of people who wanted invisibility. Total number of people who wanted invisibility was 75 total. So over here, I'm going to stick 75 divided by 450. And I put that in the calculator, 75 divided by 450, which gives us 0.166 repeating. Okay. So I go back over here, 0.166. Oh, and I got to round up that. I got to round that thousandths place up to a 7 because there's a 6 in the 10,000th place. All right. I think at this point, I would like you to pause the video and give some of these a shot on your own, right? Of course, I'm going to do these. You know how it works, but I would like you to give these a shot while you have a chance to do it on your own. Please pause the video now, because pausing the video now will help you more in the future than just watching me do it, all right? You know the deal. Watching someone do the work, it's going to feel fairly educational, right? It's going to feel like you're learning just by watching. But an essential part of the learning process is practice, right? It's practicing on your own. So please give this a shot now. Pause me. Make me be quiet for a minute. All right. I hope you paused it, and I hope you tried it. All right. It's really easy to let the video keep playing and just kind of passively learn, but that's not going to do you the best service. You're going to learn a lot more if you do some of these on your own. So I'm just putting the proper numbers in here right now, just so I can focus on the calculator in a second. But I probably want to talk about what I did too. So what I've just done, I saw that there was one female that wanted super strength, so I put 1 divided by 450. I saw that there was 25 males that wanted super strength, so I put 25 over 450. I saw that the total number of people that wanted super strength was 26, so I put, I've got a 51 in there. I didn't fix that yet. 26 total people that wanted super strength. Over here, I saw there was 70 females that wanted telepathy. Put 70 divided by 450. I haven't done these calculations yet. I'm just telling you what I did in case you can't see it because the text is so small. I got 48. I'm sorry, there's 48 males that wanted telepathy, so it's 48 over 450. Are you seeing the pattern here? There were a total of 222 males, so I put 222 divided by 450. And finally, with 450, guess what? I put in 450 divided by 450. Because hopefully you can do this right in your head, right? What is 450 divided by 450? Hopefully you know that's 1. In other words, 100%, right? 450 respondents out of 450 equals 100% of our respondents. So really what's left for us to do here is to run these calculations. So 1 divided by 450 is 0.002. Wow, a really small percentage. 25 over 250. 25 divided by 200. Divided by 450. That's going to be 0.5. Oh, no. 0.05. And then my next 5 rounds up to a 6 because there's a 5 in the 10,000th place. Must be 5.6%, right? 26 out of 450. The relative frequency of 26 respondents that wanted super strength out of 450 total respondents. That's going to be 0.058, right? Rounding that 7 up. 0.058. All right, I got telepathy over here. Telepathy 70 divided by 450. There were 70 total females that wanted telepathy out of 450 respondents. That's going to be 0.155 repeating. And when I round that, it's going to be 0.058. 156, right? 156. The 5 rounds up because there's a 5 in the 10,000ths place. All right, then I got 48 males that wanted telepathy. 48 males that wanted telepathy out of 450. Okay, so that's going to be 0.107 when I round that 6 up to a 7 because there's a 6 in the 10,000ths place. You see what I'm doing there? Hopefully you're feeling pretty good on this. And I have 1 left, thank goodness, because I am feeling like that was a lot of calculations there. All right, 222 males total out of 450 total respondents. So they're approximately 49.3% of our respondents were male, right? 0.493. Are all these done? I think they're all done. Wonderful. So we filled in this table. We've calculated the remaining relative frequency tables in the table above. We wrote the value in the table as a decimal round to the nearest thousands. We already did that. B, based on the previous work with frequency tables, which cells in this table would represent the joint relative frequency tables? And which cells in the relative frequency table would represent the marginal relative frequencies? Label on the table. Oh, label on the table? That's not easy. How am I supposed to do that? I mean, I can do that really easy with my drawing tools for Screencastify, but I don't know how you're going to do it. Here's what I'm going to do. I'm not going to label on the table. I'm going to say the cells in white are joint relative frequencies. Go. Oh, pressed the wrong button there. And the cells in gray are marginal relative. Not so slow. Cells in gray are marginal relative frequencies. And so really, now what I've said is true. I only need to change this cell right here because this cell is still white, and so I need to somehow change the cell color. No, I want to change the cell color because this is really a marginal frequency, not really relative. I'll give it that. There we go. So now what I've said is true, right? All the cells that are white in white. Oh, that's not quite true, right? Because there are still some cells in white that are not what I'm talking about. So how am I going to fix this? Not easily, I tell you, not easily. I'm going to fill these in with, I'm going to do this one with yellow. And then I'm going to get rid of this one. I'm going to get rid of the yellow on this one, okay? That's how I'm going to solve this little logical puzzle here I've got. Oh, no. Give me the more options. Give me them. I wanted those. Okay. All right, see what I've done here? So now I got to change this. The cells in yellow. All right, the cells in yellow. So I've just changed the color of my my joint relative frequencies and made them yellow. And so the cells in yellow are the joint relative frequencies. The cells in gray are the marginal relative frequencies. And now everything I've said is true. All right. What is the joint relative frequency for females and invisibility? Interpret the meaning of this value. Okay, so let's go back up. Females invisibility. It's 0.17, right? Sorry, I said that wrong, actually. No, it's 0. Hold on, I'm going to paste it to rewrite it right correctly. It's 0.107. Yeah, there we go. 0.107. And how do I interpret this? This means that there are approximately 10.7%. I need to remove a verb here. This means that approximately, I need to get rid of the R. This means approximately 10.7% of respondents were females that chose invisibility. Is there an E? Respondents? Yeah, respondents were females that chose invisibility. All right, so I'll make that bold so you'll know what that is. There we go. That's how it's done. That's how we're doing, right? So this is the number I actually had. That's the number. And I interpreted the number. This is out of a decimal out of 1, which means I multiplied this. But yes, I multiplied this by 100, right? So I took 1. I took 0.107. And in my head, I multiplied it by 100. Because I knew this was a decimal out of 1, and to convert it to a percentage, I had to multiply it by 100. And when I do that, I see it's 10.7. So I knew that there was 10.7% of respondents were females that chose invisibility, right? This is this idea of relative frequency. What is the marginal relative frequency for freeze time? Okay, the marginal relative frequency for freeze time. Well, let me go back up to my table. I see that it's 0.291. Okay, I'm just copying that. Putting this over here. I'm pasting. So go on the next page. So this means that approximately, let's see, this is going to be 29.1. Do you see how that works? 29.1%, right? So I took the 0.291, and in my head I moved the decimal place over 2 points, or 2 places. But you could achieve the same effect by multiplying by 100. 29.1, right? There's approximately 29.1% of respondents, or surveys. You could say surveys here too. I forgot the E. Respondents chose freeze time. All right, chose freeze time as their preferred superpower. All right. Do you kind of get where I'm going with this? Do you see the reasoning? Hopefully. All right. What is the difference in the joint relative frequencies for males and females who selected to fly as their favorite superpower? Okay, so the joint relative frequencies for males and females. Okay, so I need 2 different numbers because we're doing the joint relative frequency for males, joint relative frequency for females, and to fly as their favorite superpower. So let's go back up. To fly, I have 2 numbers. I've got 0.0, nope, 109. I got that number. And then I have 0.113. All right, those are my 2 numbers. And it says, what is the difference? What is the difference between these 2 numbers? Okay, so difference, when you see difference, I want you to think subtraction, all right? The difference between 10 and 9 is 1. The difference between 8 and 2 is 6, right? So difference, I want you to think subtraction. So what I need to do here is I need to subtract these 2 numbers. So I'm going to do 0.113 minus 0.109. I'm going to get a very small number. The difference is 0.004. And how should we say this? It doesn't actually explain. So I guess we won't, right? I was going to say, do we have to interpret this? Do we have to analyze it? Nope. The question doesn't ask for any of that kind of stuff. It just says, what is the difference in the joint relative frequencies for males and females who selected fly as their superpower? So difference just means subtract. I had the two numbers, I subtracted them. Is there a noticeable difference between the genders and their favorite superpower? Is there no difference between the genders and their favorite superpower? Well, let's see. Let me see. What would I say about males? I would say the most popular superpower for males was freeze time. All right. The most popular superpower for females was telepathy. Telepathy. Freeze time came in as a close second for females, and a few more males wanted to fly over telepathy. So for males to fly and telepathy were close second to freeze time. But okay, so there was a slight difference, I'd say, right? Most males wanted to freeze time. Most girls wanted telepathy. That's maybe how I would just say that. Yes, most males wanted to freeze time, yet most females wanted telepathy. There we go. Oh, that's, yeah, I mistyped that. All right, I might have to cut this video a little short because I have class to go to in 5 minutes. But I've got enough actually 10 minutes, so I have a little bit of time. The students who analyzed this data wanted to create a comic strip for the school website, and the only one power will be given to the superhero. Scott initially indicated that the character created should have super strength as the special power. This suggestion was not well received by the other students planning this project. In particular, Jill argued, well, if you don't want to ignore more than half of the readers, then I suggest telepathy is the better power for our character. Why would several students argue against Scott's initial suggestion for choosing super strength? Why would people argue against choosing super strength if you're going to do a comic? Well, super strength was like the weakest power of them all in terms of popularity, right? In terms of popularity, only 5.8% of respondents wanted super strength. So that was really not a very popular choice. So what I might say here is super strength was the least popular choice of superpower among the surveys. I could have said respondents again, but I decided to say something a little different. Why might Scott have made the suggestion? Because he was one of the males that wanted super strength. All right. Scott wanted it because he was one of the males that wanted super strength. Why would Jill say to use telepathy? I suspect, let's go back up. Why would Jill say use telepathy? Jill might say use telepathy because most girls wanted, or telepathy was the most popular choice for females, right? Because telepathy was the most popular choice for females. I don't like that this. No, yeah, I don't. Sorry for my typos. I don't like that this went down over here. I guess I'll use tab and move that over there. I guess that's better. I don't like it, but I'll move on. All right. Oh, so you maybe there's times when you want to pause the video and get a chance to write these down, right? I'm not gonna. Oh, that goofed up my. Bolded it and then it goofed up my fix. So There we go. Better. All right, Scott acknowledged that super strength was probably not the best choice based on the data. The data indicates that freeze time is the most popular power for our superhero, continued Scott. Jill, however, still did not agree with Scott that this was a good choice. She argued that telepathy was a better choice. How do the data support Scott's claim? Why do you think he selected freeze time as the special power for the comic strip hero? And how does the data support Jill's claim? Why do you think she chose telepathy as the special power for the comic strip hero? Well, let's see this. Freeze time got a total marginal relative frequency of 29.1%, whereas telepathy got 26.2%, right? Telepathy was the most popular among females, freeze time being a second place. But among males, freeze time was the most popular. Freeze time was the most popular choice, right? So it was a total of 131 people wanted freeze time. Telepathy was 118. The relative frequencies is 29.1 versus 26.2. How are we going to talk about this? Okay. How are we going to talk about this? Let's think about it. Freeze time had the highest relative marginal frequency of all superpowers, right? Freeze time had the highest relative marginal frequency for all superpowers. How do the data support Jill's claim? Telepathy was, had the second highest marginal relative frequency, but the highest joint relative frequency among females. Right? And if they wanted females as their audience, then maybe they would go with that. Something like that. We're trying to get you to be able to look at these tables and analyze them and interpret them and that kind of thing. So to summarize, categorical data is data that can take on values that are categories rather than numbers. Examples include male or female for categorical variable of gender, or 5 superpower categories for the categorical variables of superpower qualities. A two-way frequency table is used to summarize bivariate categorical data. A relative frequency table compares the frequency count to the total number of observations and can be written as a decimal or percent. A two-way table summarizing relative frequencies of each cell is called a relative frequency table. And I don't think I wanted to actually go over this in this video, and I was going to leave you with the homework, but I think I don't have time for that. So I think that's where I'm going to leave this video. And then maybe I'll make a second video possibly to cover this part if this doesn't get assigned to you as independent practice for homework and such. All right? I hope these videos are helpful, and I hope to see you in class.